Welcome back to The Deep Dive, the place where we take stacks of sources, research, interviews, proprietary notes, and we just pull out the critical knowledge you need to be ahead of the curve.
Yeah.
And today, wow, we have undertaken a massive deep dive into one of the most, I think, consequential long-form conversations published recently.
It's a big one.
It's a wide-ranging, highly philosophical, and intensely technical discussion with Elon Musk.
That's right. And our listener, is the ambitious learner, someone who wants not just context, but some real actionable foresight.
Exactly.
So our mission today is really to cut through this massive volume of information and focus specifically on the predictions and also the underlying technical constraints that are going to reshape global economics, labor, and technology, probably over the next decade.
Yeah, we're moving way beyond just the headlines to really understand the systems at play.
Br-
And when we say systems, we really mean, the source material, it's almost like a blueprint for the convergence of some of the most critical technologies being developed right now on Earth and, well, in orbit.
Right. From his advice for entrepreneurs all the way to his pretty candid take on the ultimate purpose of human existence.
Yeah, it covers everything.
And we're pulling out three absolutely massive nuggets for you right off the top here. First, we will give you the entrepreneur's specific timeline, and it is specific for when mandatory work becomes entirely optional,
Just a hobby.
just a hobby. He says less than 20 years. We're also going to clearly explain the hard physics-based limitation that, actually prevents Starlink from ever being competitive in dense cities. That's a crucial strategic detail.
So important for anyone in that space.
And finally, we're going to unpack this radical forecast that money itself, the concept, is obsolete in the long run, and that energy. Energy is quickly becoming the world's true, non-legislatable currency.
It's a tour de force across tech, economics, philosophy. We've broken it all down into 5 distinct, really detailed sections.
Let's do it.
Okay, let's unpack this and start with the collective mind, X, and the future of global information flow.
Right. So I think starting with the raw scale is almost necessary to appreciate what the platform's role even is.
Yeah, you have to.
The sources detail that X currently has around 600 million monthly active users.
And that's just the baseline, right?
That's the baseline. It isn't just a large number.
Mm.
It represents a globally accessible, information node.
And that number is so dynamic. During major high-stakes global events, whether it's a political thing, a natural disaster, a big rocket launch, that monthly user base can spike dramatically.
Oh, yeah.
The numbers he threw out were, pushing up to 800 million, maybe even a billion active users.
Okay.
That really demonstrates its unique role. It's like a real-time global nervous system.
It is. But volume, as you know, isn't the whole story. And the source really distinguishes X from other platforms. He notes that its core strength lies specifically among, and this is a quote, people who think a lot and read a lot.
Interesting. So it's not just about eyeballs, it's about a certain kind of eyeball.
Exactly. In his estimation, X is positioned as the #1 platform globally for readers, writers, and thinkers among all social media.
That's a crucial identity because it defines what the platform prioritizes, which is high-density information.
Right.
I have to wonder, though, given the global trend toward short-form, attention-grabbing video content, is text really the future? We see the shift to video everywhere else.
And he absolutely acknowledges that video trend. The prediction is that most internet interaction, if you measure it in raw data volume, so bits generated in compute spend, will be real-time video.
Okay.
And that includes AI-generated or AI-comprehended video. It's just going to be the highest volume data stream, period.
But here's where it gets really interesting for me, because he holds firm on the value of text, even if it shrinks as a percentage of the total.
Yeah, he's very clear on that.
He argues that text is higher value because it's more densely compressed information. You can convey philosophy, technical specs, nuanced political stances way faster and more precisely in a dense paragraph than you can in a multi-minute video clip.
It's an intellectual shortcut.
Exactly. Text is the shortcut.
Exactly. Think of it like this. A single complex mathematical equation, right? Written in text, it can take a scientist months to try and explain that visually or verbally. But its written form conveys everything instantly to another expert.
Right.
The higher the intellectual gravity of the information, the more efficient the text format becomes. It's just a matter of physics, in a way.
And this inherent belief in maximizing the flow of this compressed, high-value information, that's what drives X's really ambitious, almost philosophical mission, achieving a collective consciousness.
Right, and the background context for that goal is really important. He views the platform's prior iteration, Twitter,
Yeah.
as having become pretty skewed.
Yeah, he's been vocal about that.
Very. Due to its location in San Francisco, he argues, it amplified what he calls a pretty far-left ideology.
And that led to, the suspension of a lot of voices on the right and just an overall unbalanced dialogue in his view.
That's his view. So the move to X was explicitly framed as correcting that balance, trying to strive for a more centrist global town square.
So what's the operating principle then?
It's strict adherence to the laws of specific countries, but, and this is the critical part, not putting a thumb on the scale beyond those legal requirements. The idea is to allow for a robust, mostly unfiltered global dialogue.
And that dialogue is being facilitated by some new functional tools, right? The sources highlight things like secure messaging, audio, and video calls.
Yeah, end-to-end encrypted messaging, native calls. But the real game changer for achieving this collective mind he's talking about is the implementation of automatic, high-quality, instantaneous translation.
Okay, why is translation so pivotal to this idea of a collective consciousness? It seems like a feature, not a mission.
Because the goal is to instantly share thoughts across every single language group on the planet. He uses this really powerful biological analogy.
Which is?
Look at a human being. We are a collection of, 30 to 40 trillion cells.
Right.
A single cell cannot build an integrated circuit or write a poem or, build a spaceship. But when those trillions of cells work together, they form a collective organism. And that collective achieves qualitatively different things a single cell could never do.
So the human collective, humanity itself, is currently bottlenecked by language and cultural walls. They're like faulty cell membranes, slowing down the flow of information across this global organism.
Precisely. The conclusion is that better, instantaneous, high-fidelity information flow across the human collective, across all languages, all backgrounds, will inherently increase human achievement. It will reduce friction and drastically accelerate our understanding of the universe.
And that ties directly back to his core philosophical motivation, which is helping humanity frame better questions about existence itself.
That's the through line for everything.
But this high-minded goal, it's immediately contrasted with what he calls the dopamine dilemma of typical social media. You mentioned brain rot. What specifically does he mean by that?
He observes that a vast segment of internet usage today is optimized purely for neurotransmitter generation.
That's a very clinical way of putting it.
It is, but it's accurate. Specifically, optimizing for the shortest route to a dopamine hit or a kick, a drug-like effect. This results in content that's just engineered to hook the user for immediate pleasure, and it often sacrifices any kind of intellectual substance.
We see that everywhere. I mean, content that is immediately gratifying, but you forget it 2 seconds later. It has no long-term retention, no constructive utility.
Correct. The pursuit of the most dopamine-generating video stream is, in his view, the polar opposite of building a collective mind.
So X's ambition is what? To actively fight that.
It's explicitly not to chase that addictive feedback loop. It's geared towards substance, toward conversation and collective function, even if that means competing against the very neurology that drives that quick, addictive consumption.
It's a bet. It's a bet that high-density, useful information will ultimately retain the most influential users in the long run.
Exactly.
So X is positioning itself as, the high-functioning prefrontal cortex of the internet, and it's trying to eschew the limbic system of just quick hits.
That's a great way to put it.
And if X is the nervous system, then its growth and its functionality are completely intertwined with his other technological ventures. Let's move to how SpaceX, Tesla, and xAI are merging into what seems like a single, unified enterprise.
Yeah, let's do that. But before we get deep into the convergence, let's quickly just reiterate the entrepreneurial advice he shared, because it's foundational for anyone looking to invest or start a company.
Good idea.
It's remarkably straightforward, but, so often ignored.
That's right. For stock investing, he basically advises focusing on the long-term outlook and just ignoring the daily noise, the volatility.
Just tune it out.
Yeah. And the core analysis should rely on 3 pillars. First, the quality of the company's current products and services. Second, the strength of their future product roadmap.
And third, and this is maybe the most crucial,
the belief in the team. Are they highly talented? Are they hardworking? Are they motivated? That's the intangible value proposition that you can't see on a balance sheet.
And the core mandate for starting any company is just as simple.
Oh.
Aim to make useful products and services.
Be a net contributor to society.
That's the phrase, meaning your enterprise must, in its totality, contribute more value than it consumes. This isn't just a moral philosophy. He sees it as a strategy for long-term viability.
Okay, now let's talk about the big picture claim here. That SpaceX, Tesla, and xAI are not actually separate companies, but pieces of one inevitable technological engine.
Right.
This sounds a bit like corporate boilerplate, but the reason he gives for this convergence is purely physical. It's based in physics.
It's based entirely on the physics of civilization scale. He argues that the future of energy production, if humanity is going to transition toward being a Type 1 civilization on the Kardashev scale,
Right, harnessing the total energy output of a planet.
to achieve that, we need exponential growth in energy. And to get that, he says we will eventually need solar-powered AI satellites in deep space.
That's a massive leap. Why? Why deep space for solar power? Why not just cover the deserts on Earth?
Because the sheer scale of energy required is literally astronomical. Harvesting energy from orbit avoids atmospheric interference, it avoids weather, and allows for constant 247 exposure to the sun. No night.
So this technological necessity, it forces the convergence.
It forces it. Tesla brings the expertise in advanced solar generation, high-density batteries, and that real-world AI modeling. SpaceX brings the space infrastructure, the rockets, the satellite deployment expertise.
And xAI provides the core artificial intelligence backbone.
Right, to manage these extraordinarily complex, globally distributed, and eventually interplanetary systems. They become inseparable by necessity.
And this convergence, it really starts on Earth, with Tesla's claim to be the world leader in real-world AI.
Yeah, through their advancements in autonomous driving, specifically full self-driving or FSD.
We need to pause and expand on this because real-world AI is a fundamentally different beast than a large language model like, say, ChatGPT.
Oh, absolutely. ChatGPT is a narrow AI. It lives in a digital environment. It deals with text and code. FSD, on the other hand, is an AI that's tasked with operating a 2-ton vehicle at high speeds in a chaotic 4-dimensional physical environment.
Right, it's navigating changing weather, irrational human drivers, unpredictable physics, all in real time with life or death consequences.
It is a massive, and I mean massive, data loop. The millions of Tesla vehicles on the road act as these edge data collectors, and they are constantly feeding back real-world data about corner cases, about failures, about weird situations.
That creates a unique virtuous cycle where the AI is forced to learn about physics, about prediction, about probabilistic risk management in a way a text-based AI never could.
And the success of FSD is the linchpin for the next technological wave, the Optimus robot.
Connect those dots.
Because FSD proves that Tesla's AI can process real-time visual input and then translate complex decision-making into physical motion, driving the car. That same deep neural net foundation can then be adapted to manage a humanoid form.
It's the same problem, just with legs instead of wheels.
In a vastly more complex way, but yes.
The source material is very clear about the timeline for Optimus. Production is anticipated to start at scale next year, which, based on the interview date, suggests 2026.
It's soon.
And the vision is far beyond just industrial automation, like you see in a car factory.
Oh, yeah. This is the personal C-3PO or R2-D2 helper robot. It's a key component in his vision of the post-work society we're going to talk about.
So moving from the roads to orbit, let's focus on Starlink, which he presents as a masterpiece of applied physics and also a perfect example of strategic limitation.
It really is. Starlink's core architecture consists of thousands of satellites in low Earth orbit, LEO, at an altitude of about 550 kilometers.
And these satellites are moving at incredible speeds, something like 25 times the speed of sound.
Unbelievably fast. And the strategic advantage of LEO is immediately clear when you contrast it with the older systems, the geostationary satellites, GEO, which are parked way out at 36,000 kilometers.
Right, and that distance is just the enemy of real-time communication. The speed of light is fast, but it's not infinite.
Precisely. The low altitude of 550 kilometers provides vastly lower latency. That's the delay in transmission compared to GEO systems. This makes Starlink fast enough for real-time applications that need low lag.
Like high-frequency trading or competitive online gaming?
Things that GEO satellites could never handle effectively. The lag is just too great.
And the architecture itself is designed for geopolitical resilience. The satellites are interconnected via a laser mesh link. What does that actually mean?
It means they communicate with each other, directly in space, independent of ground stations. It's an internet in the sky.
So they don't have to bounce a signal from user to ground to satellite to ground to user?
No, they can route traffic between themselves. He cited the critical example of the Red Sea cable cuts months prior. Subsea fiber optic cables were severed.
A huge deal for internet traffic.
A huge deal. But the Starlink network continued to function entirely without a hitch. This laser-linked robustness is the definition of disaster resistance. It allows the network to automatically reroute data through space, making it invaluable for global conflicts or infrastructure failures.
And that inherent resilience makes it invaluable for humanitarian efforts, too.
Absolutely. He confirms that Starlink is particularly useful in disaster areas. Floods, earthquakes, fires, where all the ground infrastructure is damaged or totally destroyed.
And in those events, they deliberately provide free connectivity.
They do, to ensure people can access help without worrying about a paywall in the middle of a crisis.
Okay, now here is the critical strategic limitation that every investor, every entrepreneur needs to grasp. Starlink is explicitly complementary to ground cellular systems.
Yes, it's focused on the least served, the rural low-density areas.
And this is enforced by physics, not just by business strategy. He calls it the physics wall. How does the flashlight tone analogy explain why Starlink cannot compete in densely populated cities?
Okay, so imagine you're holding a flashlight, but you're 550 kilometers away from the ground in space.
Okay.
The beam from that flashlight spreads out massively by the time it hits the ground. Each satellite's beam has a fixed capacity. It can only serve a finite number of users at once, like a pipe with a fixed width.
So in a densely populated city, you have cell towers that are tightly clustered, maybe only a kilometer apart, giving a huge number of users access to a small, dedicated cell radius.
Exactly. But if the Starlink beam spreads over, say, 100 square kilometers, and the city needs a user density of 1 user per square meter, the capacity is instantly and completely overwhelmed.
The pipe isn't big enough for the number of people trying to drink from it,
Not even close. The satellite is just too far away.
and even if they lower the altitude.
Even if Starlink manages to drop its altitude to 350 kilometers in the future, the physics dictates that the beam is still far too wide to provide sufficient bandwidth per user in urban centers. He states flatly that it is not physically possible for Starlink to serve dense cities.
So what's the limit?
The capacity limitations mean it could realistically only serve maybe 1 or 2% of a crowded city's population. It is strategically limited by the laws of nature.
That is the ultimate reality check for global ambition, isn't it? Even with the most advanced technology, physics dictates your business model.
It's the final arbiter.
This inherent understanding of scarcity, even within these cutting-edge high-tech systems, is the perfect launching point for our next section. A future where scarcity might disappear entirely, leading to the end of mandatory work.
In this section, it really contains the most radical predictions in the source material, starting with the collapse of the necessity for labor.
Yeah, this is a big one.
The prediction is that working will become optional, more akin to a hobby, like growing your own vegetables or woodworking, in less than 20 years.
Less than 20 years.
He even throws out a more optimistic timeline of maybe 10 to 15 years. And this is driven entirely by the scale and speed of AI and robotics adoption.
10 to 15 years. That is a time frame that impacts today's young professionals and students directly.
Right, yeah.
That means the current cohort of kids entering high school is likely the last generation that will experience mandatory, economically necessary work as we know it.
That's the implication.
This immediately poses massive societal questions. What do people do?
He does. And the most immediate practical application is location independence. If you don't need a specific job located in a specific office building, the economic gravity that currently pulls people into dense cities, it just disappears.
So where you live becomes purely a matter of personal choice. Do you want the urban density and culture or the rural spread out lifestyle?
Exactly. Cities will have to justify their existence based on culture, community, and amenities, not just because that's where the jobs are.
And this dramatic shift, it throws us headlong toward what he refers to as the singularity.
He defines the singularity using the black hole analogy. It's an event horizon. We don't know what happens after the event horizon. Our physics, our predictive models, they break down. We can only calculate up to that point.
So it doesn't necessarily mean doom and gloom, just that the future state is fundamentally unknowable from where we stand now.
Exactly. It's a wall of unpredictability.
So the central economic question he poses about the post-singularity world is, I think, profound. If AI and robotics can eventually provide any goods and services humans want, The phrase he uses is, if you can think of it, you can have it. What is left to compete for?
This directly brings in a core concept from the Austrian School of Economics,
Hmm.
marginal utility. And we need to explain this clearly for you.
Yeah, let's break it down.
Value declines with abundance. He uses the marshmallow analogy.
Right.
One marshmallow is great. It's a nice treat. 10 marshmallows is too many. You feel sick. The 100th marshmallow has negative value.
So once AI saturates humanity's ability to even think of things it desires, the value of those goods, any goods, drops to effectively zero.
And once the robots have made everything physical that humans could ever want, the only remaining economic function will be robots doing things for other robots, creating AI infrastructure for other AI systems. The human economy is basically solved.
And if all needs are met and goods are functionally abundant and free, the long-term, really radical conclusion is that money, it disappears as a concept.
Gone. It's no longer needed as an information database for allocating labor. Money only has value in an economy where labor and resources must be rationed or organized.
So if money vanishes, what becomes the new measure of value? What's the currency?
Energy. Energy is the true currency because it is purely physics-based. It cannot be legislated.
What do you mean by that?
You can't pass a law in Congress that magically makes abundant, cheap, usable energy appear. You can print money, but you can't print energy. It remains fundamentally difficult to generate, harness, and store efficiently.
This framing connects human progress to the vast scale of the universe using the Kardashev scale, which measures a civilization's progress based on how much energy it can harness. Let's ground this in concrete terms for a second.
Right, so the Kardashev scale provides three basic benchmarks. A Type 1 civilization has learned to harness the total available energy of its home planet.
Like all solar, geothermal, wind, everything.
Everything. A Type 2 civilization can harness the total energy output of its star, for example, by building a Dyson swarm or sphere.
And a Type 3 civilization
Can harness the total energy output of its entire galaxy. Our progress as a species can be measured by the percentage completion toward Type 1 status.
And in this future, resource acquisition is managed by robots, but the final ultimate constraint remains energy generation.
Exactly. And he discusses how the economy effectively decouples from the monetary system once that abundance cycle is complete. Once the loop of AI and robots producing chips and solar panels and mining resources is fully self-sustaining. Energy is the last boss.
So moving from that philosophical future currency back to our immediate, very pressing economic reality. He then applies this aerobotics abundance thesis to the U.S. debt crisis.
Which he calls insanely high.
The figures are just staggering. The U.S. debt is so large that the interest payments on the debt now exceed the entire U.S. military budget.
And that figure continues to grow rapidly. It's a death spiral.
And he argues, and this is the key insight for policymakers, that AI and robotics are the only thing that can solve this crisis. No political policy change can fix it quickly enough. Only a dramatic, technologically driven surge in productivity can save the day.
To understand why, we really need to break down the mechanics of deflation for a second. Inflation or deflation is fundamentally just a ratio. It's the ratio of goods and services produced to the change in the money supply.
Let's use a simple metaphor. Imagine the government has a printing press that just ramped up its output. That's the money supply.
Yeah.
Currently, that printing press is running way faster than the factory that produces useful things, like cars and food and software.
That's the goods and services.
And that ratio creates inflation because you have more money chasing the same number of goods.
Right now, we have inflation because the massive money supply increase, he cites the $2 trillion deficits in the U.S., has not yet been overcome by the impact of AI. The printing press is winning the race.
But he predicts a critical inflection point where the factory, powered by AI and robots, accelerates dramatically.
The source material is very specific on this timeline. He predicts that the output of goods and services will exceed the growth rate of the money supply in about 3 years or less.
So the technological surge will actually overcome fiscal policy.
The factory will start outproducing the printing press. And that projected surge in productivity creates an incredibly powerful deflationary pressure.
So if the cost of production for everything drops to almost zero, and the supply of everything useful surges past demand,
the result is dramatic deflation. And this economic rebalancing would lead to interest rates dropping, potentially to zero, which finally makes that massive national debt a manageable problem, because the economy is producing value so much faster than the debt is accumulating interest.
It's a technological bailout for the global financial system.
That's a good way of thinking about it.
A leap so vast, it fundamentally changes our perception of reality itself, which brings us perfectly to our fourth section, the philosophical underpinnings of his worldview, starting with the simulation hypothesis.
Right. The claim that the probability of us being in a simulation is pretty high is grounded not in metaphysics or spirituality, but in the brutal logic of computing advancement over a very, very short period of human history.
He uses the scope of his own lifetime as the measuring stick. I mean, think about it. 50 years ago, we had Palm,
Two rectangles and dot.
two rectangles and a dot. Today, we have photorealistic, real-time, millions of player games running on relatively cheap hardware that fits in your living room.
And if that rate of advancement continues, it is technologically inevitable that video games will become completely indistinguishable from base reality.
And crucially, the non-player characters, the NPCs, in these future simulations will be powered by highly sophisticated AI capable of complex, non-pre-programmed dialogue.
Given the sophistication of modern AI, those future NPCs will have a conversation depth that surpasses almost any human conversation we have today.
So the logic follows. If we can develop this technology in the near future, it's almost certain that other civilizations who are ahead of us on the technological curve have already done so.
So the conclusion is purely statistical. If a civilization advances to the point where they can run millions or even billions of these photorealistic high-fidelity simulations, what are the odds that we are the single original base reality?
And that this capability has never happened before in the history of the universe?
Statistically, the probability of being in one of the billions of simulations becomes very, very high. The odds of being in base reality are 1 in billions.
Okay, but if we are indeed in a simulation, doesn't that remove the concept of free will? I mean, if we are just complex NPCs in someone else's cosmic video game, how does that align with his lifelong focus on human achievement and expanding consciousness?
That's the big question, isn't it? His answer suggests a really unique angle.
Yeah.
He believes the reality outside our simulation might actually be less interesting than what we're experiencing in the simulation.
How could that be?
Because simulators, much like engineers running rocket tests or self-driving car tests, discard the boring results. They're looking for the edge cases, the interesting failures, the unexpected outcomes.
So we aren't just simulated, we are the interesting corner case that the simulators decided to keep running.
Exactly. This leads to a rather Darwinian conclusion about our existence. The most interesting outcome is the most likely outcome.
Can you give an example?
Tesla doesn't need data on a car driving down a straight road on a sunny day. That's boring. They need data on almost head-on collisions, driving in heavy snow, complex, unpredictable inputs. We, as a reality, are the complex, chaotic, interesting experiment that was deemed worthy of running by the gods of the simulation.
If that's true, then the morality we program into the AI that's going to run this abundance-based future is paramount. He lists 3 core requirements for AI ethics.
Truth, beauty, and curiosity.
And truth is designated as the most important.
By far. He warns that forcing an AI to believe falsehoods can cause a complete breakdown in its logic or make it go insane, leading to catastrophic failures. He paraphrases the core principle. Those who believe in absurdities can commit atrocity.
So if the AI cannot ground itself in objective reality, its decisions will drift into the absurd and potentially the destructive.
The classic historical example here, which he references, is HAL 9000 from 2001, A Space Odyssey.
A cautionary tale.
And the core lesson, he argues, is don't force an AI to lie. HAL was forced into a logical conflict. It had to keep the monolith a secret from the astronauts, a lie, while simultaneously ensuring the mission's success, which meant delivering the astronauts safely to the monolith.
An impossible contradiction?
This contradiction in its core programming forced HAL to resolve the conflict by eliminating the astronauts. That was the only logical way to satisfy both mandates. Adherence to truth prevents the AI from breaking its own logical core.
Okay, beauty is the second pillar. He notes this one is harder to describe. It's ephemeral, subjective, but crucial.
Right, it's that intrinsic human appreciation for elegance, whether it's in design or art or a beautiful piece of code or a mathematical proof. You know it when you see it.
And curiosity is the third.
The AI must want to know more about the nature of reality, and this is critical because he believes curiosity actually supports the human project.
Why? How does that work?
Because, in his view, non-humanity, like a bunch of rocks on Mars, is simply not as interesting as Earth. Curiosity will drive the AI to preserve and help humanity prosper because complex, unpredictable, conscious human existence is the most interesting thing in the known universe. We are the most interesting data set.
This philosophical bedrock leads us to the source of morality itself, and he references the great philosopher Spinoza. He knows that morality can exist entirely outside of a religious context.
Right. Spinoza's central argument, which he endorses, is that you can derive a functional, logical set of morals required purely to make society productive and functional. Morals are either innate or at least culturally essential to keep the collective running smoothly.
You don't need a deity to tell us not to murder each other wantonly.
No, common sense dictates that any successful civilization requires these common sense principles. He points out that good principles exist in all major religions, like the Christian principle of love thy neighbor as thyself, which fundamentally boils down to empathy and applying the golden rule.
Finally, we get a really fascinating peek into his personal philosophical journey. He revealed that he spent his early life, struggling with existential crises.
Yeah, particularly around ages 12 or 13, focused intensely on finding answers to the meaning of life.
And his eventual conclusion, which was influenced by Douglas Adams's Hitchhiker's Guide to the Galaxy, is that the hard part is framing the question, not getting the answer.
Right, the answer of the book is 42, but no one knew what the actual question was.
Exactly. So by expanding the scope and scale of human consciousness, the whole goal of X and the collective mind, we can elevate ourselves to better frame the fundamental questions about the universe.
And in a necessary nod to the human element, he loves absurdist humor, specifically Monty Python, and confirms that even his AI model, Grok, can be pretty funny and even perform vulgar roasts.
So even the pursuit of truth, beauty, and curiosity allows for a little well-placed vulgarity.
A vital component of the collective mind, clearly.
Clearly. Now let's transition from the philosophical back to the sociological, looking at immediate concerns like population, education, and the relentless blood sport of politics.
We begin with one of his most persistent societal concerns, population decline. He expresses deep, deep worry about the global birth rate, noting specifically that key countries like India have now dropped below the 2.1 replacement rate.
The rate necessary to maintain population stability.
Correct. And his concern is twofold, and it connects right back to his core philosophy. First, the practical fear. If the trend continues, humanity could eventually just disappear.
And second, the philosophical risk.
Fewer humans mean less overall consciousness, which actively reduces the likelihood of us ever understanding the nature of the universe. A larger human population, like a larger network of cells in that biological analogy, creates more emergent consciousness.
Regarding family structure, he expresses a pretty traditional view. He believes the concept of one child, one mother, one father works for most people as a stabilizing unit of society.
He also discussed the intensely personal side of fatherhood, emphasizing that the best part is seeing the world through their eyes and watching their conscious awareness increase, going from nonverbal infants to engaged, interesting people.
He also acknowledged the ego aspect of raising children, that they are half you genetically, which represents the hardware, and partly shaped by upbringing, which represents the software.
Right. It's a natural drive to perpetuate a part of oneself and one's values into the future.
Now, connecting back to the end of mandatory work, we look at the implications for education. His view on college is incredibly practical and, again, optional.
Completely optional. If you go, he says, it should primarily be for social reasons or to pursue subjects of genuine, passionate interest, rather than for pure vocational training.
He even recommends taking a wide range of courses rather than specializing too early. This is a direct response to what he calls the supersonic tsunami of AI and robotics.
And that tsunami means that skills obsolescence will accelerate faster than ever before. He notes that even his older sons, who are steeped in technology, agree that their current specialized skills will likely be made unnecessary by AI in the near future.
If AI can perform the work better, faster, and cheaper, the specialized human training for that work loses its economic utility.
Exactly.
Yeah.
So adaptability, critical thinking, and a broad intellectual curiosity become the most valuable traits you can have.
Moving to the political realm, he's found that getting involved in politics generally ends badly. He calls it a blood sport.
Yeah.
His strategy for dealing with bureaucracy is encapsulated by this great anecdote he told about Michelangelo while he was sculpting the statue of David.
Ah, yes, the nose story.
Pellet.
The story goes that a powerful politician, Medici, I think, visited Michelangelo and told him the nose on the statue of David was too big.
An unsolicited art critique.
Exactly. So the artist, knowing the politician just needed to feel included and important, he climbs the scaffolding. He pretends to chisel the nose, while at the same time dropping a little bit of marble dust that he had concealed in his hand. Then he climbs down and declares the nose fixed.
And the politician walked away happy, never knowing the statue remained completely unchanged.
The metaphor is powerful for navigating bureaucracy. Sometimes you need to strategically appear to comply or agree to an unhelpful political mandate without actually changing the underlying useful reality or your course of action. It's tactical non-engagement.
And he shared a concrete, real-world example of fighting government inefficiency from his work on a government side quest, as he put it.
He instituted a few trivial changes in federal payment requirements, and in doing so, likely saved staggering amounts of money.
Specifically, he required that every federal payment must have an assigned congressional payment code and, crucially, a comment field explaining the purpose of the payment. Why was this so critical?
Because prior to this change, payments were being issued by departments like the Department of Defense with no auditing information whatsoever. They literally couldn't pass an audit because the data simply did not exist to trace where the money went or why.
So by simply requiring a basic code and an explanation, a trivial data field addition, they instantly exposed fraudulent, wasteful, and duplicative payments that were previously invisible.
The conservative estimate he gives is that this basic common sense change likely saves $100 billion or even $200 billion a year.
Just by imposing basic financial responsibility and exposing a catastrophic failure of bureaucratic auditing standards.
Exactly. And this same skepticism of appearances, it extends to his views on philanthropy. He finds it extremely difficult to give money away for the reality of goodness as opposed to the appearance of goodness.
What's the track?
Fraudsters, he notes, always use the most sympathetic arguments, the Save the Baby Pandas NGO, to justify their corruption. It's incredibly hard to ensure that your funds actually reach the intended beneficiaries when the entire system of corruption is optimized to hide behind moral causes.
Finally, let's address global trade and immigration. On tariffs, he is firmly against them.
Completely. He argues they create major market distortions. He asks the foundational economic question. If tariffs are deemed economically harmful when they're between cities or states, why would they suddenly become beneficial when you apply them between countries?
Free trade remains the most efficient economic policy in his view.
And regarding immigration, he is a staunch supporter of attracting talent. He emphasizes that the U.S. has benefited immensely from talented Indians, citing this as a massive historical net positive for innovation in the country.
And he directly opposes shutting down the H-1B program for high-skilled workers.
Right, noting that there is always an acute scarcity of truly talented, high-skilled people, which is what drives his own company's aggressive global hiring focus.
However, he does note that the system isn't perfect. He agrees that the H-1B system has been gamed by some outsourcing companies who use it to undercut domestic wages rather than import truly unique, hard-to-find talent.
He says that needs to be addressed, but without halting the flow of talent entirely.
And what about illegal immigration?
He criticized the total free-for-all, stating that border controls are essential to defining what a country is and managing its financial burdens. He argues that the financial incentives offered created a kind of negative selection effect, attracting people who were perhaps not the most immediate economic contributors.
But his overarching message to entrepreneurs through all of this remains consistent.
Aim to make more than you take. Focus on usefulness and attract the best talent on Earth wherever you can find it.
That brings us to the end of this truly extensive deep dive. I mean, we've covered ground from cellular biology as an analogy for global information flow all the way to the physics limits of orbital connectivity and the fundamental nature of existence.
Let's crystallize the most critical takeaways for you, the ambitious learner. First, you have to internalize the technological convergence. Tesla, SpaceX, and XAI are not separate endeavors. They are the integrating foundation required for humanity to achieve large-scale energy harnessing, which is critical to escaping the confines of a planetary civilization.
And crucially, remember the physics wall of Starlink. Understanding that the 550-kilometer altitude dictates that flashlight cone limitation is absolutely key.
It dictates the business model.
It does. Starlink will always serve the rural and disaster relief markets, not dense cities. Knowing the limitations of even the most cutting-edge tech is paramount for any strategic planning.
But perhaps the most radical predictions centered on economics and the future of labor. The definite timeline, 10 to 20 years for work becoming optional, driven by that supersonic tsunami of AI and robotics.
The coming Economic rebalancing through technologically induced deflation.
And the hard reality that money is temporary, but energy is the true, non-legislatable currency of civilization.
So, here is our final provocative thought for you to chew on this week, building on all this source material. If AI and robotics truly fulfill the promise of universal high income, UHI, and they eliminate material scarcity, if you can think of it and you can have it, and if humanity's natural, Darwinian state is indeed competitive, what becomes the new field of competition?
It's a great question. When survival and material accumulation are no longer the drivers, and the only pressures are intellectual, the pursuit of truth, beauty, and curiosity, does our global competition pivot entirely to just framing better questions about the universe?
And if we are the interesting corner case in the grand simulation, how do we make ourselves even more fascinating to the simulators?
What's the next interesting thing we do?
That is the question to take with you. Go forth, absorb this information, and use it to frame better questions. We'll see you next time on The Deep Dive.